This mini lecture is about rotamers and conformations, and we're going to start off with a discussion of torsional angles. Torsional angles are the angles between this hydrogen and this hydrogen down here. Now let's take a look at a different way of showing this. Now what we can do is, instead of viewing it from the side like we are here, we can view it from the end. So our eye would be here and we're looking down this carbon-carbon bond right here. This carbon would be this carbon right here, and this carbon you can't see because it's directly behind this one. We could tell the difference between the hydrogens that are attached to the different carbons by looking at their size. The bigger ones are attached to the front carbon, these smaller ones here are attached to the back carbon. Now what we've done is we've designated these four atoms right here, and we're going to investigate the angle between this bond and this bond. So we take those out and we lay them on a plane, and you can see that it's completely flat. That means that there is an angle of 180 degrees between this bond at the back and this bond at the front. That's called dihedral or torsional angle. If we rotate this around a little bit, we can now get a different dihedral angle. This one would be 120 degrees. Right, we're going to keep track of this bond as we rotate this and take a look at some of the energy changes that are occurring. This is called a staggered conformation. In this conformation you can see that the hydrogens are pretty much as far apart as they can be from each other, and we're really looking more at the ones at the back relative to the ones at the front, and you can see that there are not too many interactions going on. So that's a low energy type situation. Now what we're going to do is we're going to look at what happens when we rotate this 60 degrees, and we're going to rotate it from 180 to 120 on the dihedral angle. Now here's what I'm talking about. If you take this, it's almost like a circle, and it's a circle that's been split into 6 parts. A circle is 360 degrees. If you divide that by 6, that's 60 degrees. Let's rotate it 60 degrees and see what happens. Right, so we've rotated it 60 degrees, and now what's happening is that the hydrogens at the front are now in front of the hydrogens at the back. We call this situation eclipsed. This is a very high energy situation because now we're having interactions between the hydrogens that are close together. And because they're eclipsed, we've got a very large energy here. We rotated another 60 degrees, and here's what we're seeing. We're seeing a staggered conformation again. The same conformations we had before, the same energy. So now we're getting a much lower energy situation after rotating it another 60 degrees. We rotated another 60 degrees, we'll go back to being eclipsed, etc., etc. So it'll just look like a sine curve when all is said and done. And we're just rotating 60 degrees each time.